In this application, we're going to use the Acuity white light confocal CL4 probe with an MG35 magnifier, and we're going to be looking at these targets up here, and we're going to be scanning in to look at surface roughness on the 7 different samples. As you can see here on the top link cover, the conical cover, the Isotech arm cap, and the Intex arm cap. We're going to be taking data on these to validate the white light confocal is going to measure them. We're going to use our CL4 probe, and we're going to scan at a 6 millimeter by 1 millimeter density over that scan, and we're going to take 4 microns by 4 micron data point along that surface, and that's going to give us, for each scan, we'll be taking 376,751 data points over the scan to create this 3D cloud of points model. So we're going to look at the first scan here, and this is sample number 1, and as you can see, we went 6 millimeters by 1 millimeters along that sample, going 4 microns by 4 microns. And what we're going to do is we're going to take a look. This is the 2D scan. Let's take a quick look at what this looks in 3D. And just to give you an idea of what that scan looks like as we zoom that up. And you can see that we're getting very good data from the white light confocal probe. And we're going to delete that, and we're going to come in and we're going to take more of your standard profile measurement. And let's focus on all these scans. We'll take approximately in the middle, going from west to east across that scan. And here's that profile going the 6 millimeters across that, and we can take a look at that surface roughness. And this is an ISO 4287 parameter, and here's all our amplitude parameters, and here's our R sub A. We're showing about 6.51 microns across this one profile. It's also possible with this technology to take a look at a different scan. Instead of just a simple profile, we're going to take a look at the area scan, looking at all the data points, and we're going to look at the ISO 25178 standard, where instead of R sub A, it's called S sub A for that surface area, and we're showing for that whole surface area of about a 9.46 micron S sub A. So what it allows you to do is to look at that full surface and get a much broader view of that measurement. So that is the first sample, and let's come down and look at the second sample. So here's our second sample. Pretty much we pretty much set everything up exactly the same way. Let's take a quick look 3D so we can see what this, to basically validate that this scan is also, the probe's doing a very good job on this scan also. And just to sort of show you an idea of the resolution of this probe, I mean, we can really zoom this thing up and get down into the micro surface features of this part. So all that data is there. Let's come back in and we'll take, once again, a profile across here, and we will do the west to east, approximately in the middle of the scan. And of course, we could go north to south or oblique, or we could go pretty much anywhere that we wanted to, but just to sort of keep it all the same data. And here we're going to take that number, and we're showing once again an R sub A of about 6.28 on this surface on sample number 2. And let's look at that total surface area. That S sub A is about 8.8 microns. So that's sample number 2, and we'll quickly go to sample number 3. Everything else is set up the same. Let's just go right into looking at the profile. Approximately in the middle. Put it to absolute, and let's look at, now we're going to look at this surface roughness here. We're showing about a 6.51 R sub A across here. And we'll look quickly at this measurement. We'll keep them all in the same place. This is the ISO 25178 with an S of A of about 8.72 microns. We'll move on to sample number 4, and we'll take a profile across approximately the middle. We'll put that in absolute scale, and let's look at that surface roughness. R sub A of 8.59, and let's look at that quickly. We'll look at that surface area roughness of 13.6. So obviously much rougher over this total surface. And let's come in and look at sample number 5. And we're going to take a profile across that sample. And of course with this profiles, we actually do have, we can change this and put in filters, Gaussian filters, if we ever needed to. So we can plug all that information in, but we're just looking at the raw data. And let's take a look at that profile roughness, R sub A of 11.2, a little bit bigger than the other ones we've seen, sample 5. And we'll do a quick surface, and here we can see once again our S of A is about 14.5 microns. So let's go on to sample number 6, and let's take that profile roughly across the middle of the scan. Put it in absolute scale. And here's our surface profile roughness of about 9.19 microns. And that whole surface area is going to have an S of A of about 15.6 microns. Sample number 7. We will take a look at that profile. You can tell it definitely looks a lot more rough on that sample. And we've got a R sub A of about 6.8 microns and that total surface of about 15.4. So you can see that we'd hit one section here that probably wasn't as rough as there are a lot in that sections. This is pretty much just a real quick example of how the Acuity white light confocal can collect that data. And as you can see with these 7 samples, we've collected a lot of data relatively quickly. We used a little XY stage that's accurate to 0.1 microns, and we're able to collect this very good data that can be used to validate surface roughness on your parts.